Hello mathletes, Dave Staublin here. We're going to do some good math. Now we are going to start on page 19 in your packet. But before I put notes in that packet, I want to do a quick overall picture of the things that we've been learning. You do not need to write this down at this time. I just want you to follow along so you can see the big picture. All right, with quadratic functions, we have standard form, which looks like this. Y equals ax squared plus bx plus c. We have vertex form, which looks like this. Y equals a x minus h squared plus k. And we have factored form, which looks like this. Y equals a x minus p x minus q. Okay, so again, you don't need to write this down. I just want you to follow along. Each of these forms gives us different information. For example, this is the y-intercept, and this tells us whether it opens up or down. The vertex formula, we have an A, and again it tells us whether this opens up or down. But we also get the vertex. Lastly, in the factored form, again we have the A, which tells us whether it opens up or down, and then we get the two x-intercepts. So each of these gives us a different piece of information. Standard form gives us the y-intercept at 0, c. Vertex gives us the location of the vertex at h, k. And factored gives us the x-intercept at p0, and the other one is q0. Okay? So that's what we have learned so far. Now what we are going to do today is learn how to transition or transform the equations from one form into another, so that if you have factored form in the x-intercepts, you can transform it into standard form and get the y-intercept, and so forth. So, with that in mind, let's get our pencils out, let's get our packets out, and go to page number 19. Okay, so over on the side here, I wrote the general equations for each of the equations. So for example, standard form is y equals ax squared plus bx plus c. The next one down is factored form, which is y equals a x minus p x minus q. And then the third one down is vertex form, which is y equals a x minus h quantity squared plus k. All right, so keep in mind if you need to pause the video at any time, you may do so. Okay, so we are going to transform standard form into factored form. So the first thing we want to do is factor out the greatest common factor. So let's look at that. How would we do it? Well, I see that all of these numbers are even, and I see the x squared is negative. So we're going to factor out a negative 2, and when we do that, we'll be left with x squared minus 2x minus 15. And we can double check that by doing distributive property. That would be minus 2x squared plus 4x plus 30, so it works. Step 2 is to factor. So relieve the negative 2. X times x is x squared. And now we got to find our factors of 15. Hopefully you still have your factoring sheet that has all the combinations. But for 15, the factor pairs are 1 and 15 and 3 and 5. We need to find a pair of these that multiplies to negative 15 and adds to negative 2. And that would be plus 3 and minus 5. Multiplies to negative 15, adds to negative 2. And so now we have successfully transformed from standard into factored. Okay? Now, let's do the next idea, which is going from factored form to standard form. So we're basically doing what we did up above backwards. So here's what we're going to do. We're going to start by multiplying the binomials. That means these things. So we're going to write the negative 3, and inside the giant brackets, we're going to distribute. X times x is x squared. X times negative 2 is negative 2x. 4 times x is 4x. And 4 times negative 2 is negative 8. Now, we are going to combine like terms. So 4x minus 2x is plus 2x. And we have the minus 8. Okay, so that is multiplying the binomials. Now we're going to distribute the negative 3. So we would have negative 3x squared, negative 6x plus 24. And now we have transformed from factored form into standard form. Okay, we have one more. We are going to convert vertex form into standard form. So step number 1 is to square the binomial. That means this. So we are going to rewrite this as so. X plus 3 times x plus 3. That is squaring the binomial. So let's do that. We would have x squared. We would have 3x plus 9. So that's that part. Oh, it's actually not done yet because we need to combine the like terms. So x squared plus 6x plus 9 minus 4. All right, now we've done square the binomial. Now we have to distribute the a value. So minus x squared minus 6x minus 9, and then we have the minus 4. And lastly, we have to combine these like terms, and so I am going to do that right here. So y equals negative x squared minus 6x, and then that's minus 13. So we have successfully transformed from vertex form to standard form. And we did it. Now it's not easy. There's a lot of multiplication in algebra and combining like terms, but you can do it. Now, at the very beginning, I gave you the big picture of the different forms, and now we're going to apply that. What do we know about the following parabolas just by looking? Well, this one is factored form, so we know this tells us that it opens down, and then these values give us the x-intercepts. So it's going to be negative 2, 0, and 8, 0. Those are the x-intercepts. Looking at this one, we can identify that this is in standard form. So we know from this number that it opens up, and we know this is the y-intercept at 0, 2. Moving on, this one is in vertex form. So we know that this one opens down, and then we know the vertex is going to be at, let's see, opposite sign, negative 5. No, positive 5, and then 3. So yes, that's correct vertex. And then this one is another vertex form. What's missing is the plus 0. So this number means it's going to open up, and then we know that the vertex is going to be at negative 2 and positive 0. All right, so that is transforming quadratic equations. I hope that was helpful. If you need to go back and look at the video again, feel free to repeat it and pause it and stop it as much as you need. Your assignment is to do the problems on page 20 of the packet, and when you finish those, look back through your packet, and there are some pages that we didn't complete during this past week, and see if you can finish those up too. All right, thank you for being attentive and focused and good math students, and I'll look forward to seeing you the next time I'm in class.